In this question, you start off with annual payments of $300, and then it keeps dropping by $30 per year. So it drops to $270, and then $240, and then once it reaches 90, it's just gonna level and then remain at 90 until the end of the 15-year period. And at a 4% interest rate, we want to find the present value. And so as always, when in doubt, draw a diagram. So this thing lasts for 15 years. And then we're told that it starts off as $300, and then it's gonna keep on decreasing, and then up to a certain point it's gonna reach 90, and then it's gonna stay at 90 all the way to time 15. So first of all, we need to find when it drops to time 19. And one thing you can do, of course, is to count your fingers. But another way, of course, is to use a general term. So you can set up a general term like this. So you can imagine this expression being the amount that you pay at time t. So at time 1, you pay 300, just substitute 1 here, so you get 300. Substitute 2, you get 270. And you want to find when it reaches 90. So all you have to do is just to dump the numbers over to the other side. And you see that t is equal to 8. So at t equal to 8, the payment is going to reach 90, and then from then onwards, it's going to stay at 90. So the question now is to find the present value. And one way we could treat this is to break this up into 2 separate payments. So first, I'm going to imagine a level payment of 90 all the way from time 1 to time 15. So I'm going to imagine this payment over here to be a combination of this payment and then a second annuity payment over here. So if you combine these two, I'm going to put another annuity payment here, and if you combine the two of them, you're going to get this. So if I already have this payment over here, what we need to construct this payment will be $210 over here, and then you just do the math, it's $180 here, and then you keep on going, and then it's going to last till time 7. So at time 8, it pays 90, and then in this annuity immediate over here, we've already covered for these $90 payments. It's just that there's an excess over these $90 payments in the period from time 1 to time 7. And then from time 1 to time 7, all we have to do is just to add a decreasing annuity. So it's going to keep dropping all the way to $30 at time 7. So at time 7, you're going to receive $120. And that's going to be a combination of $90 and $30. So the reason why I broke up the annuity payment into these 2 components is so that I can use our annuity symbols to combine them together to get a value of the present value of all these payments over here. So the decreasing annuity that we need to consider will stop at time 7. And then this annuity payment here is going to start from time 1 to time 15. And this stops at time 7 because it's just how this payment works. At time 7, you get $30. Combine it together, you get $120. And then later onwards, it's going to level at $90. So you don't need to add anything starting from time 8 till time 15. So all we have to do now is to combine the present value of these two separate annuities. So the first thing that we have is a 15 payment at 4%. So the effective rate is 4%. And then over here we have a decreasing annuity. So we just apply the formula. And this lasts for 7 payments. So now that we've drawn the diagram, we can easily see how all the payment works. We can easily break it up, and then by breaking it up, we can come up with these 2 simple formulas. So recall that an annuity symbol N that looks something like this refers to a payment that starts at time 1 with N, and then it's going to keep on dropping all the way till time N, till it's equal to 1. So this is what this symbol describes, and if we multiply 30 to this symbol over here, it's going to give us exactly what we see over here. It starts at 210, and then it decreases by 30 all the way to time 7. So recall the formula for this expression. So just substitute that in. So in this case, I is 4%. So after you substitute all your numbers in, you're going to get your answer. It's going to be equal to 1,749. So the main point of this question is how to break all these payments up into 2 separate annuities and then to use annuity symbols to add them back together.